Hey, what's up? It's Jake from Nimbus DevOps, and I'm going to finish out this section on comprehensions by talking about dictionaries and sets. So let's get started. Let me clear this out. Let's make a new file, and we'll just call this dictionary set.py and get started. So dictionary comprehension works exactly like list comprehension, but to construct a dictionary, there's a slight difference in the syntax, and this will explain pretty much everything you need to know. So if I say from string import some ASCII lowercase, and then I'm going to just make a set, and I can say A is 1 and B is 2, like this, so on and so forth. And you can go down to like Z, right? So let me pause it. So I decided I'm not going to do this because it's a giant waste of time. So what I'm going to do instead of making this set is I'm just going to make a letter map. So let's do letter map equals, hey, get out of here. And we'll make a dictionary and say C, K for K, comma, C in enumerate, which I've used before. And then we'll just go ASCII lowercase, comma 1. That should give me what I want. Yeah, and then let's just print our letter map. Python dictionary set, not discount, dictionary set. There we go. A1, B2 through Z26. So that was a way faster way of doing that. So all I'm doing is enumerating over a sequence of all lowercase ASCII letters using the enumerate function, and then construct a dictionary with resulting letter number pairs as keys and values, much like you would zip something. And the syntax is similar to the dictionary syntax you've seen before. There's another way to do this. The other way to do this would be by going like this. So we're still going to make a letter map, but I'm going to say use a dictionary function, and then in here make a C and a K, right? And then for K, C in enumerate, ASCII, underscore lowercase, comma 1. Something like that. Yeah, and then print letter map. And let's see if we can do it this way. Okay, same result. So in this case, you feed the expression to the dictionary constructor, and dictionaries don't allow duplicate keys. So we're going to, in this case, they're all unique. So we're going to take a different way of doing this and look at maybe there's some duplicate stuff that we can mess with. So I'm going to take positions. Actually, let's not do that yet. Let's make a word, hello, and then swaps equals, and then let's make a dictionary, C dot swap case for C in word, something like that. And then let's just print swaps and see what that does. H goes to lowercase h, E goes to uppercase, L goes to uppercase, O goes to uppercase. That's interesting. So we created a dictionary with the letters of the string hello with the capital H as keys and same letters, but with the case swapped as values. So we have a key value pair, and there's only one L pair. You'll notice that. So it's actually HELO because it doesn't allow for duplicates, like I was saying before. The constructor doesn't really care. It just reassigns the duplicate to the last value. And we can make this a little clearer to assign positions in a string. I can show you that. So if we did our same word, right, and we comment this out, and instead we're going to look at positions in the string and say positions, dictionary object, C, K for K, comma, C in enumerate on word, and then we can print positions and see what that does. H0, E1, L304, or 04. Okay, so the value associated with the letter L3, and because the L2 pair isn't there, it's been overridden by L3. So you'll notice the position goes 0, 1, 3, 4, and it just skips 2 altogether. Because as it goes through and enumerates on word, when it gets to the second L, remember I said the value is assigned to the previous value? So, well, that includes its position as well. So you got to be careful when you're looking at duplicates, because what you think should be in a certain position inside of a sequence might actually have a different position if there's a duplicate, but the value of that will be reflected in whatever the second, in this case L, would be instead of the first, giving you position 0, 1, 3, 4 instead of 0, 1, 2, 4. Hopefully that makes sense. So then the last thing I'm going to do is some set comprehensions, and let's just delete all this and let's make a word again, but we'll do hello. We'll stick with hello. And this time I'm going to say letters 1 is dictionary object, C for C in word. Okay, pretty simple, right? And then I'm going to make a letters 2, and I'm going to make a set, C for C in word. So we have dictionary object, then we have a set. So if we print letters 1 and spell print correctly, and then I just want to print out whether or not, I want to know a Boolean, is letters 1 equal to letters 2? Well, let's find out. Yes, EHOL. Okay, so that's kind of weird, right? What the heck is that? For set comprehension, just like dictionaries, duplication is not allowed, and therefore the resulting set only has 4 letters. Also notice the expression assigned to letters 1 that we have there and letters 2 produce equivalent sets. It's true. The syntax used to create letters 1 is very similar to that of a dictionary comprehension, and you can spot the difference only by the fact that dictionaries require keys and values separated by colons while sets don't. So for letters 2, we fed a generator expression to the set constructor. So this is your generator expression. So there you are. Hopefully that makes sense. As we get into this now, it's probably appropriate that we talk about generators, so that is what I will do next.